Hi, I'm Song. Here is the class of Probability and Stochastic Process, homework 10. And here is the video of the problem 1. Firstly, let's read the problem. From my lecture notes, page 1 to 50, collect the definitions and simple properties, probability masses or density, mean, and autocorrelation function of examples of stochastic process. Okay, let's solve this problem one by one. Firstly, is Poisson process. The number n t1, t2 of the points ti in the interval t1, t2 of the length t, which equals t2 minus t1, is a Poisson random variable with parameters lambda t. Is a Poisson random variable with parameter lambda t. So it's the probability of n t1 t2 equals to k, which equals to e to the negative lambda t multiplied with lambda t to the kth divided by k. To the k factorial. And here is the first condition, the first situation. And the second one is that if the interval t1, t2, and t3, t4 are non-overlapping, then the random variables n t1, t2, and n t3, t4 are independent. And the third situation is that at the time moment t, there is no more than one Poisson point. There is no more than one point. And then we form the stochastic process. Xt equals to n 0 to t. And the first order probability masses is that the probability xt equals to k, which equals to e to the negative lambda t multiplied with lambda t to the t's divided by k factorial. And the mean is that ext, which equals to lambda t, and the autocorrelation which is rt1t2 equals to lambda squared t1 t2 plus lambda mean t1 t2, and the autocovariance is c t1 t2 equals to lambda squared t1 t2 plus lambda mean t1 t2 minus lambda t1 lambda t2, which equals to lambda mean t1 t2. Okay, this is the first one, Poisson process, and then the second one, Poisson increment process. The second one is Poisson increment process, which is defined as yt equals to xt plus epsilon minus xt divided by epsilon, where x is Poisson process, first order probability masses is p yt equals to n divided by epsilon, which equals to e to the negative lambda epsilon to the nth divided by n factorial. And the mean is e yt, which equals to lambda, and the autocorrelation which equals to r t1 t2 equals to lambda squared when t1 minus t2 larger or equal with epsilon, and which equals to lambda squared plus lambda divided by epsilon minus lambda t1 minus t2 divided by epsilon squared when t1 minus t2 less or equal with lambda epsilon. And the autocovariance which equals to c t1 t2 equals to 0 when t1 minus t2 larger or equal with epsilon, and which equals to lambda divided by epsilon minus lambda t1 minus t2 divided by epsilon squared when t1 minus T2 less than epsilon. And here is the second. And the third one is point impulse process. Point impulse process is defined as ZT equals dxt dt, where xt is Poisson process, and the probability masses, there is no definition. And the mean, which equals EZT equals to lambda, and the autocorrelation, which equals to RT1-T2 equals to lambda squared plus lambda c multiplied with T1 minus T2, and the autocovariance, C T1 T2, which equals to lambda sit T1 minus T2. And the next one is semi-random. Okay, next one is semi-random telegraph signal. Which is Pn T1 T2 equals to K, which equals to E to the negative lambda t's multiplied with lambda t to the k's divided by K factorial, and xt equals to 1 when K is even in the row T, and which equals to -1 when K is odd in the row T. And the first order probability masses, which is the pxt equals to 1, which equals to e to the negative lambda t multiplied with e to the lambda t plus e to the negative lambda t divided by 2. And the pxt equal to -1, which equals to e to the negative lambda t multiplied with e to the lambda t's minus e to the negative lambda t's divided by 2. And the mean of this is ext equals to e to the negative 2 lambda t's. And the autocorrelation is RT1 T2 equals to E to the negative 2 lambda multiplied with T1 minus T2, and the auto covariance is say T1 T2, which equals to E to the negative 2 lambda T1 minus T2 minus E to the negative 2 lambda T1 plus T2. And the next one, random telegraph signal yt equals to axt p8 equals to 1 is p8 equal to a half, which equals to half, where xt is semi-random telegraph signal. And the first order probability mass which equals to the probability of yt equals to 1 equals to pyt equals to negative 1, which equals to half. And the mean is yt equals to 0, and the autocorrelation, which is RT1 T2 equals to E to the negative 2 lambda T1 minus T2, and the autocovariance, which is C T1 T2 equals to E to the negative 2 lambda T1 minus T2. Okay. And the next one, which is random walk. Toss a fair coin n times. K is the number of heads in n tosses, and xnt equals to ks minus okay, here is the definition, equals to ks minus n minus k multiplied with s, which equals to 2k minus n multiplied with s. And the first order probability masses is probability of xt equals to xnt, which equals to rs, and which is n plus r divided by 2 for nt less or equal to t less than n plus 1 multiplied with t. And the mean if xt equal to 0, and the autocorrelation is RT T1 T2 which equals to E x T1 x T2 which equals to the xnt xmt which equals to mean nm multiplied with s squared, and the auto covariance which is ct1 t2 equals to e xt1 xt2 which equals to E xnt xmt which equals to mean nms squared. And the last one, Wiener process, which is Wt equals to lim t to 0 n to infinite s squared divided by t2 which equals xt, where xt is the random walk, and the first order density function is f Wt equals to f omega t which equals to multiply with e like this, and the mean is e Wt equal to 0, and the autocorrelation is Rt1 T2 equals to mean T1 T2 alpha, and the autocovariance which is ct1 T2 equals to mean T1 T2 alpha. Okay, that's the first problem we have solved it. Thank you.